Hi students. So in the previous session we discussed about the problems of first question from exercise 13.2. So today I am going to teach you the problems of second question from exercise 13.2. So see the heading here, the heading of the second question: simplify and express each of the following in exponential form. So here the first question is the first problem is 2 raised to 3 into 3 raised to 4 into 4 divided by 3 into 32. So here we have to write this whole in the exponential form. To write this whole problem in exponential form, here we have to use the laws of exponents wherever needed. So see here, upside the bases are not same here. Here is the 2, here is the 3, and here is the 4. Bases are not same. If he wants to add the powers, the bases are not same here. Downside, we face the same problem, that the bases are not same here. So in such type of condition, here we have to do some modification. So how? See here, this 4 we have to modify it as a exponential form, or we have to write this 4 in the form of exponential form. Similarly, this 32 also we have to write in the form of exponential form. To write this 4 and 32 in the form of exponential form, first we have to find the prime factors of both these numbers by doing the prime factorization. See here, first I am going to write this 4 in the form of exponential. See here, 4, 2 2s are 4 and 2 1s are 2. 2 2s are 4, 2 1s are 2. Here 4 is equal to 2 square. How many 2's are here? 2. It means, see here, put the equal sign and remaining write as it is. I mean 2 raised to 3 write as it is, 3 raised to 4 write as it is, and this instead of 4 we have to write 2 raised to 2. Similarly, this 3 write as it is. Again we have to find, or again we have to write this 32 in the form of exponential by finding the prime factors of this 32. 2 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4, and 2 1s are 2. So 32 means how much comes it is? It is 1 2 3 4 5. Here we have 5 2's. So 32 means it is how much here? 2 raised to 5. Next, now here 2 raised to 3 and 2 raised to 2, both these exponents have same basis. Here we have to add both these, okay? And upside is 3 raised to 4 and downside is 3. Here it is possible for us to do the division, okay? First we do the multiplication of the exponents here. 2 raised to 3 plus 2. 2 raised to 3 2 raised to 3 into 2 raised to 2 is equal to 3, 2 raised to 3 plus 2, and this 3 raised to 4 write as it is, okay? And downside also write as it is. Here you have to write the reason, because a raised to m into a raised to n is equal to a raised to m plus n, okay? See the next one. See the next step. 2 raised to, here we have to add the powers. 2 raised to 5 into 3 raised to 4 divided by 3 into 2 raised to 5. Here 2 raised to 5 is upside, and one more 2 raised to 5 is downside. 3 raised to 4 is upside, and 1 3 is downside. See here, if this 3 it doesn't contain any power, we have to understand that there is a 1 is there. Okay, there is a 1. So any number it doesn't have power, you have to consider there is a 1 is there. Okay, now here we have to use the second law of exponent. I mean, a raised to m divided by a raised to n is equal to a raised to m minus n. So 2 raised to 5 minus 5, and this one into sign right as it is. This 3 raised to 4 also right as it is. This 3 raised to 1, you have to do this 1 we have to do here subtraction, because here the bases are same, here also 2 the bases are same here. Again 2 raised to 0 into 3 raised to 3. So here we have to write the reason, because a raised to m division a raised to n is equal to a raised to m minus n. Okay, here we have to write the value of this as a 1, because if any base it has a power as a 0, the value of that whole exponent is how much? It is a 1 into 3 raised to 3. See, if you multiply any number by 1, we get that same number. Therefore 3 raised to 3 is the solution for this first question. Okay, let me solve the next one, students. See the third problem, students, all of you here. 25 raised to 4 division 5 raised to 3 is the problem is here. So here also the bases are not same here. One is 25 is there and one is 5 is there. So here it is not possible for us to do the division here. So that's why again we have to do the modification here. So how we have to convert this the 25 as a, we have to write this 25 in the form of exponents by doing the prime factorization. See here, 25 5 5s are and 5 1s are. So 25 means how much it is? 5 raised to 2, 1 2. We have to write here 5 raised to 2. Okay, 25 means how much it is? 5 raised to 2, and this one 4 we have to write like this. Okay, 5 raised to 2 means it is a 25, and 4 we have to write as it is, and this one also write as it is. So it is 5 raised to 3. Here we have to use the power to power law of exponent. I mean, a raised to m bracket raised to n is equal to a raised to m into n. Okay, I mean 5 raised to 2 into 4. This one again write as it is. So 5 raised to 8 division 5 raised to 3. 4 2s are 8, and this one 5 raised to 3 we have to write as it is. So here you have to write the reason. A raised to m raised to n is equal to a raised to mn. Again here we have to use another law of exponent, that is a raised to m division a raised to n is equal to a raised to m minus n. Okay, here because a raised to m division a raised to n is equal to a raised to m minus n. So here we have answer as a 8 minus 3 is equal to how much comes here? 5. So 5 is the solution for this third question. Let me solve the next one. See the sixth question, students, all of you here. Here the problem is that 2 raised to 0 plus 3 raised to 0 plus 4 raised to 0. This problem is very easy. So all of you know that if any base it has a power as a 0, the value of that exponent is 1 1 1. 1 plus 1 plus 1. So the answer is 3. So this 3 is the solution for this sixth question. Let me solve the next one.